what is serverless architecture, some of the design goals and principles followed when you have serverless architecture, some benefits and why you should be using it, and then some real-world implementation of this concept. Right, so this is what we'll learn. We'll just talk about some background and then jump into serverless architecture, design rules and principles, and then why we should be using it, and some real-world implementation of this design pattern. Right. So this is what we'll learn in next 1 hour. And so key takeaway, all of you, once you attend this session, what is that you'll be taking away? So you'll be probably breaking your servers and embracing the whole serverless architecture philosophy. Yes. So let's jump into the topic right away. So before we talk about serverless architecture, I just thought of giving some background to the folks who don't know client-server architecture. So when we say serverless, what exactly is used instead of serverless, right? So this is client-server architecture. So we have multiple clients. It can be different devices, user agents. So mobile or desktop or multiple desktop, laptops, whatever. So people using apps on mobile tablet devices or browser-based websites. And then when you say something, the request goes to a server in the backend, and that server can be application server or web server, and it can have in the backend a database server or maybe a Hadoop cluster or XYZ. It can be anything, a file system or whatever. So that's the client-server architecture that you request from your end. You are the client, and then a request goes to a server. It gets resolved. Some logic gets triggered there. Something happens, and you get a response back on your screen or on your app, right? Based on what you're requesting for, right? You get an output. So that's typical client-server architecture. Now, when you talk about client-server architecture, there are technologies like Java, .NET, PHP, Python, JavaScript. These days we have server-side JavaScript as well, right? So these are the technologies are used to build this application, and these are web application backed by or not backed by some sort of backend, which can be NoSQL, SQL, Hadoop, real-time streams and whatnot. So that's your client-server architecture. Now, if we want to build this client-server architecture-based application, what are the steps involved, right? Typically, today, what we do is we write some code in whatever languages that I just mentioned. If you have SQL in the backend, you write that as well. So developers write the code, then they compile the code, and then once the compilation and validation testing has happened, the build is generated. And finally the build is deployed on a server. Okay. So once it is deployed, it is an application which can be used by the clients who are requesting for contains from it, right? So that's the typical scenario of how client-server architecture works, right? Any question? Basics. Right. So when you have this approach, what are the prerequisites? So you need to have machines. It can be hardware, can be VM. You need machines for your application server as well as database server. Right? So let's take an example that we are building a Java-based application, which is a transactional application. Net banking, right? So you will have, as a client, you'll have your browser on your laptop, desktop. You can just do your bank net banking login, or you have an app on mobile, right? So when you log in, the request goes to the backend, and the backend will have an application, authentication service, a page after authentication where you go, and when you transact, there is an application which has the presentation layer, the UI that you see on screen. It has the business logic layer below the UI, and then they have database access, right? Because your data is stored in some sort of database. So you'll need all of that. You need a VM hardware. You install, configure, and manage your application server. So it's a Java-based application, can be Apache Tomcat, can be WebLogic, WebSphere, any Java container, right? Application container, gateway container is what you need to install, configure, and manage before you launch your application. Then you need runtime environment for compiling and execution. You need someone to take the code either manually or in automated fashion, create a build out of it, and go to deployment on the server in a way that server accepts, including all the configurations and tweaks that you want to make on an application server, right? So writing a Java code, then compiling, then building, then giving it to a deployment engineer, or like you're deploying, you have to configure it on Apache Tomcat or WebSphere WebLogic, wherever you're doing. Do the deployment, application is launched, and on an ongoing basis, you are monitoring and supporting that server. So let's say something goes wrong with your hardware or a VM, your server is no longer available, your application is down. Let's say hardware and VM is up and running, but something goes wrong with your Apache Tomcat or WebSphere or WebLogic, your application is not running, right? And then obviously the code issues that you have, So those are the things you'll be supporting and managing. So that's today's scenario. That's how.
The network also.
Correct. Network. Yeah. Right, so those are the scenarios, that's a prerequisite to launch any client server-based architecture, right? That this is what we do, let's say a Java-based application, we have to figure out, hey, so I need Java 8. Does it work with this version of OS? What size of machine do I need for this kind of workload? What should be the RAM? Should I use Tomcat or WebLogic or WebSphere? Once I use that, how much RAM I should be allocating because of my workload? And then everything is defined, and you procure, you set up, then you deploy your app, and you continue monitoring. That's the workflow as of today, right? So let's move out of this and move to a serverless scheme of things, right? So what is serverless architecture? The word itself is non-technical. It's more of a gift from marketing world, right? Serverless architecture. Because the way technologies are built, Java, PHP, .NET, even server-side JavaScript, right? They cannot run without a runtime. Every technology will need a different runtime, but even in the scheme of things, serverless architecture, you need a runtime. But we are saying serverless, so let me explain how is it a marketing term, right? So I think last month, all of us saw something like this. Apple launched new devices, and they said, we have now wireless charging. So there's a port, and on top of that you put all your Apple devices, and they call it wireless charging. But if you notice something little, it's wireless for you, but it's not really wireless. It needs wire, it needs power, everything is same. It's just that you don't have to plug that wire in your devices. So same concept is applied to serverless architecture, that you are not using server, but that doesn't mean that whatever you're trying to do doesn't use any server at the end of the day, right? So there will be server obviously in picture, but we will learn how you will get rid of all those headaches and steps that we just saw in the past, right? All right, so let's move forward. Any questions so far? No? Okay. All right, so when serverless design started, getting traction, one of the key component of serverless design is the microservices architecture. How many of you understand microservices architecture? Good. All right, so I think a lot of you don't understand. Let me just explain what is microservices, right? So let's say we have one application. Let's talk about net banking as an application, right? One application that does a lot of things. A lot of functionalities are built in. It has transaction, it has transfer, it has maybe change your profile. Lot of things are available in net banking, right? And you think as that as a one monolithic application. Like earlier days, what used to happen was there was one application that was doing everything. There were components and modules within that, but there was one application. One application was deployed on one server and it was doing everything. The monolithic way of doing things. And then came microservice architecture. So concept of remove the logic and create a web service or a service out of it, right? So for example, you have this 5 functionality built into one application. You break down and create 5 different deployments and use everything as a service as and when you need, right? Like for example, a typical workflow in a typical client-server architecture will have one Java class, and it will have functions, and it will have function of transfer. It will call another Java class to do profile change and stuff like that, right? But it's all within the one application. Now think of that. The environment where the application is sitting, it has 5 more servers, and that 5 servers are hosting 5 services. And what your code is really doing is like, oh, I need authentication service, just call authentication service, which is not my code, but someone else's code, and which is used by a lot many people, not just me. Similarly, transfer logic. I want to do transfer. Instead of me writing that in my code, I'll write in a separate way and expose that as a service and consume that instead of me writing and bundling in my application. So breaking down things into smaller parts and exposing everything as a web service is called as microservice architecture. Right? So the web services themselves are running on some servers. Correct. It needs a server. Yeah. It needs a runtime basically. So microservice architecture is the heart of serverless architecture. Second piece is BAS, backend as a service. So we learned SaaS, software as a service, then came EAS, platform as a service, then all this cloud platform brought in IaaS, infrastructure as a service, right? So you need a VM, go to Google Cloud, go to Azure, go to AWS, click, 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 and you get your VM created, right? You don't care hardware or anything. All you're doing is requesting for a hardware infrastructure, and someone is giving you that as a service, right? So that's IaaS, and similarly backend as a service, right? So how about I write my code and forget about the backend, and use that as a service instead of me worrying about, hey, I need VMs, I need hardware, I need to install my application server. Next is a function as a service, right? FAS.
Can you give some example of what is the backend?
Sure. So let's say that I have an application running on my Tomcat, right? So we talked about software as a service, where my entire application is available to someone as a service. And then we talked about platform as a service, right? So I don't have an application, but I have a platform, right? Platform is like a bunch of functionalities built together, and I'll just call services as and when needed.
So platform could be Cloudera.
Yeah,
right. It's a platform.
Right. Then we have infrastructure as a service, where you have VMs, you have servers, whatever you need. And backend as that which is running somewhere, right? So that is backend as a service. We'll go in detail and understand that. Next is a function as a service. Okay, so going one step beyond just asking for Tomcat or WebLogic or WebSphere as a service. Function as a service is my own functionality. I'll just write very small piece of code instead of writing Java main or entire Python code. I'll just focus on the logic that I want to write. That's about it. And everything else I want someone else to manage, and I want to use that as a service. That's a function as a service. And no ops. I want to get rid of all the DevOps and IT over it, right? Just want to write my code. I know my business logic. Want to write my code and want to launch my application and write code. So these are the key concepts behind. Yes.
Function as in a code function, or function as in a functionality. You're saying like the front end functionality is same, but I'll add a logic which I wanted to use.
Correct.
So that function would pick my everything.
Correct. So here is the thing. Function as a service example is that, let's say you have a code which reads from Hadoop cluster or Amazon S3 or Google, machine learning library, right? in a typical scenario, you would just write that integration in your code, right? Like JDBC or DBC connection, or call that machine learning API, and then do your stuff. Then do your logic, actual logic that you want to do. How about you borrow a service which does all of that, connection and integration? You just care about writing your logic, right? Like borrow the functionality, right? That part.
So isn't that similar to microservices that you described before?
Yeah, microservice is the architecture, but FAS is like actual functionality built using microservice as a concept.
And all these come under serverless because I'm not hosting a server.
Correct.
All the things that I borrow are
Yes.
already on some server and just use
Correct.
them.
Yes, that's right.
Can you maybe talk about a little bit of a design criteria for microservices? When, like, how you should really think about designing it?
Sure. Yeah. All right. So these are cool concepts, but not meant for every use case. And when should you be using that, right? Like for example, let's say I'm working on a project and I need some sort of machine learning capability that Malay is building, right? And I don't know, let's say anything about machine learning, and he knows what he's doing, but his stuff is very tough for me to install and manage and take care of. I don't want to do all that. And he's setting up his own data center. He has GPUs. I have nothing of those. Okay. How do I use that? In a typical scenario, we would just say, Malay, give me all of your stuff. I'll host it on my data center. I'll buy GPUs, or I'll buy cloud VMs with GPUs, and install, configure, and use your code type integration with my application and do whatever I want to do. Versus, I say, Malay, can you give me HTTP URL for pre-processing? How do you cleanse your data? How do you do PHI scrubbing? He's doing 5 steps in his whole algorithm. I want each of those broken down as a different component, and I want to consume just as a HTTP URLs versus me having to go through setting up GPU-based data center and installing these packages and running and compiling and building those things, right? So consideration is, when you want to move away from ops, when you know that there are certain functionalities which will be used by many more users, you want to make it truly multi-tenant, and there could be a scenario. For example, his text mining algorithm works well, but depending on what source you're dealing with, right? You may have different pre-processing steps. The cleansing of data that, let's say, you're getting good data from social media, Twitter, WebMD, Facebook, these are the sources, and he's doing text mining on top of that. Now, depending on each of these sources, we'll have different needs to cleanse and extract the relevant information out, because everyone will give information in different ways and shape and form, right? So how about Malay writes that core algorithm once, and in other services in a way that, in my workflow, if I'm dealing with Facebook, out of Malay's 5 cleansing services, I'll pick 2, which are relevant for Facebook, but the core algorithm I'll pick same as a service. Similarly, so chop and change based on what you need. Reusability is, at the heart of microservices architecture.
So typically, is this used when in the kind of scenario you described, you and Malay work for the same company, but you're just compartmentalizing what you do versus he does, but both developing one application functionality at the end? Or is it more commonly used in the industry where you are not actually connected to somebody else, you happen to find this microservice and just use it randomly? Which is the...
Yeah, so AWS is entirely run on microservices. So is Google Cloud, and so is Azure, right? So all of this, S3, everyone heard S3, right? So can anyone say what is the full name of S3? Amazon AWS S3. Simple storage service, right? So it's a microservice. Someone has written, you give the data, you don't worry where it is stored. You will have 99.669 availability and reliability, and that service will take your data and put it wherever it wants on AWS's data center, right? So that kind of thing. It has GET operation, put operation, right? And similarly, everything else on AWS is a microservice. So that's a good example of microservices.
So, ideally, if you want to break it down, it means like it's a Lego block.
Correct.
Right?
Correct.
Which can match
Right.
whichever way you want to do.
Yeah, and you can build like different, Lego art out of those blocks, right? It's not like just one thing you can build out of it. All right, any other question? Yes.
Can we convert our existing application to microservices?
Yes, you can.
Is that
But one thing that, like I said earlier, right? So when you start converting, you have to understand: are you, are you trading the performance by modularizing things? Like you are doing too much data handshake between different components. Like read the data from here, transfer the whole data to this, then do something, then transfer here. Then it doesn't make sense. So you have to just understand, performance, scalability, security, and then break down entire applications into logical parts and call it microservices.
is that something our existing application should be implemented under web services? Then only we can convert into microservices program.
No, I mean if you have any Python, Java, .NET, whatever code, right? You have to write wrappers on top. So instead of doing tight coupling that you have done today, for example, just write wrappers and call those functions from outside, right? And have one class which is like an orchestrator, keeps on calling those services, which you can consume internally or expose externally as well.
Krunal, can you give some examples of how microservices is used in the FA context? Like in FA, there are so many different modules, there's that, right? Give me some examples.
Yeah, sure. So workflow MAP, FA MAP, if you have seen the demo of UI or FA MAP, it has a workflow designer and it has different steps, which is pick your source, pick your transformation step, pick your sync, right? So those all are microservices, right? So you are unifying all of those services in one canvas called workflow designer by dragging and dropping, but in the back end, everything is as a service, web service, right? So let's say I say that I don't care about your sources. I'm like hard coding my source as Oracle or HDFS or whatever. I just need those transformation services. So we can expose those as an API. Second example is the data science part, right? So every step of cleansing and algorithms is exposed through microservices. So within the component itself, the communication is through APIs. It's not like hardwired.
It's all the REST APIs?
Yes, REST APIs.
So no other way implementing microservices.
You can, I mean, but REST APIs are like,
The best.
yeah, the best. Easiest way to deal with handshakes.
Can multiple apps use the same sort of, I guess, container of the microservice?
Multiple applications using same.
Like two different FA projects,
Yeah.
they can use the same
Yes.
microservice.
So in context of FA, yes, and also overall, yes. That's the whole purpose of building microservices, right? Like we gave an example of S3, simple storage service. So we are using within Saama, 10 different projects we are using S3, and like millions of other people right now are using S3, which is a multi-tenant service. All of them are using same service. Okay, can we move forward? Any more questions? All right.
Any questions in the chat?
Is there any question on chat? Yeah, yes. All right, so serverless architecture. So this is an example illustration when you break down your, let's say when you want to do serverless deployment, how does it look like, right? So we had clients, which we still have here on right-hand side, and there was a server in between, and the communication was happening in response requests. Still today also, here are the clients, and there will be response, and there will be request and response. But now you see all the blue or green, whatever you see here, are the microservices. These are the actual components, right? So you have client components, you have database and search indexes and whatnot, right? So let's say there is one application which does search, which does some transaction on database, and also there has to be some trigger alerts and notification when something changes in the data, right? Let's say these are the 3 key functionality. So the diagram we saw earlier, everything was sitting in one box, and there was one application to deal with all these three scenarios, right? Over here, we have broken down that into three components, and we have implemented three different functionalities as three different functions, right? So what happens is the request comes from right-hand side. Obviously, it is authenticated, goes to gateway, and then based on where it has to go, it calls different function. This is just, so I'll get to it what is function. Calls a different function, does the job, gives the response back. Similarly, where it has to go and what it has to perform, right? So it's not just like, someone requests and then it works. In the bottom one, function 3, is basically, a trigger. Like, data, something has changed on your data site and you want to push notification, so you can do that as well. So many such scenarios you can cover. So what exactly is this function, right? So this function is nothing but the code that you've written without you deploying your code, on a VM, on a server, on a hardware. This is just your business logic. That's a function, right?
So where is it deployed?
Huh?
Where is it deployed?
Right, we'll get to that. So yeah, I can explain now. So where it gets deployed is, let's say, so real world implementations are like cloud platforms, AWS, Google, Azure, like they've implemented this concept really well.
Okay.
They've scaled it really well. But let's say we were to build it for Saama, internal, right? So assume that you will have a user interface where you can go actually log in and write your own code, or you can just upload your own code. Just the code, okay? And you'll have some guidelines like use this keyword, use this function, and write everything within that. So what happens is that, let's say in case of AWS Lambda, right? They have something called an event handler. So you have to implement event handler function. Whether you write it in JavaScript, Python, or Java, doesn't matter. .NET doesn't matter. You can just write that. Either you go into AWS console, type your code there within that function thing, or you can write offline and upload your code in a zip file or whatever, right? Just code, not a var, jar, nothing, just your code. So let's say you've done that. So what happens is now, when we go to the next step, so you upload our code and verify that everything is okay, there are no compilation error. Then these services, like for Saama, let's give an example. You have a user interface where you written your code, and when you say publish, so there will be another service running in the backend which will detect what language of code you've written. Take that, register into actual runtime, which you don't have to bother about.
Yeah.
All you care about is write a code. Depending on you've written in Java, C# or Node.js or whatever, right? Python. It takes that, configures with the entire environment that this code is coming up, and it doesn't care about the logic that you've written. It cares about which function you've implemented. So let's say event handler function is something about if I receive email, trigger this workflow, and pass the email, read the context, do the text mining, give me an alert that what is the inside out of it, right? That's what I want to do. So as soon as you receive an email, and your code has everything within that event handler thing, which the platform won't care, which we build, we don't care. You just register your function. We'll just take that, we need to trigger this piece of code when Latif receives new email in his mailbox, we'll trigger this, right? So system registers your code and configures for that particular event. It initiates basically that it is Java-based code. So I'll launch some JVM, some runtime somewhere, which event you have opted for. I'm listening to that consistently, constantly I'm listening. And as soon as I listen that there is an event happening, I'll push the trigger to orchestration service, which in turn, executes your code and does the logic, right? So here what you've done is, when you start writing your application, you'll have to create a workspace in Eclipse or, Atom and, import all the packages, write everything, connect to this notification service, connect to that, and then write this much of business logic. You'll write so much of code just to build an application, right? So we've cut down all of that. All you're doing is just writing your business logic and uploading, or even actually going there and coding.
So So two questions.
Yes,
How do I debug and optimize my code?
correct. So that's another,
Okay.
yeah, we will talk about that.
Okay.
So how different is this from Lambda? AWS Lambda?
The Lambda is an implementation of this.
Okay.
Yes,
Do we need a cluster to run this microservice program?
no. Well, not cluster, but like you want to be scalable and highly available, then you do load balancing and other stuff.
Okay.
The entire idea is you don't need a
Not,
server.
you don't have to do that. Whoever is providing you those services will do that.
Yeah, but there should be a cluster in the background, which will be, our orchestration, all of that will be done behind, right? To run all of these microservices.
Not necessary.
So trying to understand, right? I mean, the serverless part of it. See, this concept like SOA implementation 20 years back also had this similar concept where there was like something like an ESB, which is trying to broker. So there were things like WebSphere, WebLogic, a whole bunch of tools. New ESB had a whole thing, right? So which was doing that similar orchestration. In this case, what you're saying is that even with orchestration, there there would be a couple of VMs which is triggering these things. Here, even that is serverless.
Yeah. All right. So let's take a real life example. So very common example if you read a lot of AWS material, right? Which is I have a image cropping service. Like for example, you have a lot of websites where you upload your image for profile picture. It crops and puts it into the small size. Let's say that's my service that I'm running, right? So I will let you upload an image through website, and my entire thing is running serverless. Okay, so it does everything on a web, but it's serverless. So how it happens is that I'll let you upload the image through web, but it goes and sits in, let's say, in my Amazon S3. I'm giving AWS example. That's why goes and sits in my Amazon S3. Your image, whatever dimensions and resolutions, whatever format it is, right? My code will listen to that. If there is a new image in S3, pick that up, run this Lambda code, which will do image minimize, 200 by 200, and then put it into another location and give you that image back as a response, which on screen you see, like, can I upload this or I want to tweak this or whatever, right? So let's take that an example. So I want to do that. Now, in AWS world, what I have to do is go to console. I have an actual designer where I say this is my Lambda function, which is implementation of serverless. I'll write my piece of code, which is very like 4 lines in Python, right? Just take the image and make it small and write it to S3, right? So I'll say my trigger is S3 upload. Here is the S3 bucket that I'm listening to, and then as soon as there is something new, pick it up, give it to me as an input, and I'll just do and write it back. Right?
So again, this has been, say, for example, just to take that example, if AWS, GCP, even Azure has this whole bunch of libraries where I don't even need to bring it to myself.
Correct.
On the HTML, on the browser itself, I'll say, call this service from Microsoft, which does the image cropping and give it back.
Yeah.
Where I don't even need to write into S3 at all.
Correct.
Everything is out there in the service.
Correct. So that's even further delegation, right? In this example, you have functions available, so there your code becomes 4 line. That's what I said. Right? Just call that function, and it reads from image from. What we've done here is that, like in a typical scenario, if this is my website, right? Like I'm doing image cropping, image analysis, or whatever, right? I would go to Abhishek and say, I need a VM on AWS. He'll ask what size, approval form. I'll go back to Abhishek, I need root access. So once he gives me root access, I'll install my Python 3.6 because it comes with 2.7, whatnot. And then I'll do actual work, right? Versus here, and it's dirt cheap. If you take a AWS example, Lambda function, which is implementation of serverless, first 1 million requests is free. And after that, every 1 million requests, you're paying 20 cents.
When they increase the price, it used to be 10 cents.
Yeah, correct. 20 cents, right? Versus you need at least one EC2 instance for this, and it will cost you at least 40 cents an hour.
And you need one guy.
Yeah, and then other steps
So
that
this-
I mentioned, right?
And after that thing is done, that it releases all memory and RAM, everything. So you're paying for whatever memory or RAM that you're using.
So the only thing is serverless in terms of the context that for me it is serverless.
Yeah, it's
But I am pushing it out the server to someone else.
yeah, it's like
You're not, so it's like you said, infrastructure as a
It's not a
service. You're not,
less. In the
It's
true
not a
sense,
true
I mean, I understand what
you
you're
saw
saying,
that
but
iPhone example I gave, right? You were here.
yes, it's infrastructure as a service. You're not managing the data.
No, that's all right.
Someone else is managing
so,
it.
so Krunal saying, we were here, we saw the example, now stop asking questions.
Right, so this is an example. They launched and they say wireless charging, right? So all the devices you can charge wireless, but if you just pay attention to this image, right?
There's one right there.
Right, so it's wireless for you, but the thing, the port needs to be charged, right? It's
So
the
now
same
I have to take that thing everywhere with me to charge. Oh, Apple account, it'll be there, it's supposed to be there everywhere.
Getting input and storing that data. So would that be necessary to use services to do the storage as well?
Can you repeat your question?
Yes, yes.
Yes,
So most of the time when we do this kind of service, right, there is the need to store
The data or
information,
output.
The data, the input itself.
correct, yeah.
Now, would it be necessary to use their service to do the, to store the information as well? Like I would have to use S3 to do the storage, or would I also be able to do the storage? So use their services or their compute to compute your information and then store it back to a local environment.
Yeah, you can do that. So let's abstract out from AWS, right?
Mhm.
Let's say we have implemented that.
Yes.
So let's say you're writing some machine learning, but first step for you is to take an input and persist somewhere, right?
Yeah.
So think of that, like I gave an example to Parul, that do you want to write all that JDBC code or, maybe REST API or some, MongoDB connector that you read from here and write from there? No, right? All you want is as soon as it is there, it has to be here. And you want to delegate. All you're writing is one event that read from here and write there. That's all, right? And then whatever you want to do is just your core machine learning work. You don't want to get into all the connections and building and all that, right? So you can use that as well.
Just to add to that, you should be able to do it, but then the problem is, latent data transfer, right? You might be in East Coast, their server might be on the West Coast.
Right.
So that's again a performance.
No, but this could be invoked as a service.
Yeah, it's asynchronous, right? You're not waiting for it.
No, I'm saying that again.
You can invoke a service from within that,
Correct.
right? Another service from within that to call something else. You
So
can configure
if
that.
you go to this cloud platforms example, for example, AWS, Google, or Azure, right? They are very smart. So let's say you want data from one of the S3 bucket, right? You are sitting in West. Your data is there stored in East, US East, right? So they're not going to use API container from West. They're going to just delegate that request. They have a lot of components to do all of that. So those things are taken care of.
So your data would be in both the data centers?
Correct. No, just
No,
you
it's-
don't care, right? When you put
No, but physically the CDN, the content delivery network,
yeah,
that
Oh, they
actually
move push
factors
yeah,
in,
that
yeah,
multiple places.
yeah,
The front, yeah.
So even the high impact apps like Netflix, that's how it would work, is that they push it out.
Netflix is all on
CDN.
AWS.
Everything is on AWS.
100% AWS.
Hey, from the security point of view, right? So all the customers are concerned about their data.
Mm-hmm.
So when we say it's serverless and we are distributing the data on unknown servers, so how would the security compliance will be?
Correct. So we're not saying we are distributing on unknown servers, right? So when you write that function that I'm saying, event handler, right? You just read, maybe write one more line, two more lines, where it is coming from, detect that and put it the way where it should go, instead of just saying put my data. In case of AWS, you can do all of that. You can actually isolate different data sets for different customers. You can have IAM, AWS IAM roles and policies that who can access that data set.
Yeah, that brings to another interesting question, right? Where would the compute run? Right, like, should I have an ability to control where the compute runs? Let's say
Correct.
I have like only certain IPs where the compute can run, then it doesn't become a serverless architecture anymore, right?
Correct.
Controlling.
Correct.
Then probably it doesn't fit.
So we'll address that in the limitation part. I have one slide. Any more question on this before we move forward? I just have 2 more slides. One is on benefits, other is on limitations. On this one, any question?
So the listening service, right? I mean, how do you, is that also, so depending on the network, like how you are set up, right? And so the listening service itself, how do you design that? The orchestration listening service. You said that someone is constantly listening that, hey, is there a trigger? Or someone is sending such a request. Where do you run that?
2 ways. So when we say we're listening, right? It's just that our ears are open and someone will come and whisper in our ear, so we know. Or versus you're going where the source is and keeping your ear open to capture whatever you want to capture, right? So I'll give you an example. So let's say that whenever there is a file upload, I want to do XYZ operation, right? So I have a listener service that Soumya Banerjee as a user has registered this function, which wants to listen to this some SFTP location. Wherever there is a file upload, he wants to do blah, 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 whatever. So that listener is there, and then there will be trigger from.
I actually want to go one level deeper.
Yeah.
Say, if you're looking at, say, something like a Apache web server, or Tomcat web server, anything which is coming an HTTP request, if I go to the access log, I'll see that, here is where it came, what happened, and then I am routing it.
Correct.
So here is, what is that listening, like at that level, what is that listener that is actually receiving it and then routing it to someone? Is it at a network layer or is it at a software level?
It's a service layer.
At a service layer.
Yeah, it's a software level.
You mean a port or something, listening on a port or something like that?
Not a port, I mean, so you have a service always available, and which is, do something, like, that's your service, which is listening. Do something in the context of his SFTP upload. Now, SFTP upload is also a service. As soon as it is finished, it will just pass a message, right? It's done. So this guy will go and trigger another service, which will pick the files and do whatever it has to do. So it's handshake. See, typically in a cloud platform, they use queues for this.
Correct. Like, in the old world, you would have your router itself, right? That can, you have a web setup, right? There itself, you can implement some of these routing services that you receive this request. Where do you want it?
Yeah, but when you go to that level, right, we're just talking about one use case. This could be email received, this could be database field change, this could be whatever, right?
There's a comment from Chaitanya Swamineni that it is done using SR.
But we're talking like overall, not just AWS, right?
Does this imply that if you are calling services, that if you are on AWS and all of the services will be on AWS, or is it even that is interchangeable?
It's not, unfortunately. So that's one of the limitations. Let's go there actually. So real world implementation, let's just AWS Lambda, we've been talking about that. There is something called as functions in Azure, Microsoft Azure. Google has cloud functions. IBM Bluemix Cloud has OpenWhisk, and there's a webtask.io. So all of these are like popular serverless implementation. You don't have to even create that whole string, you can just use that.
Krunal, this will be also be limited by the languages, right? So the kind of language it can support. I can write in C, C# or any language.
Correct.
So out of this 4 or 5, is there some, everybody adheres to all the languages, or it is some limitations across all the 4 platforms?
Generally, they support all the languages which is supported in a web world. So I'll come to that. So first point is the limitation, vendor and platform lock-in, right? As of today, very few organizations have maturity to build their own serverless architecture. First of all, there has to be some demand and usage that, let's say we build here, the whole serverless thing, we create that Lambda equivalent for Saama. Are there enough consumers to use it? So that brings to the thing that, let's move to some cloud platform where they've already built and scaled, and it's like, secured or whatever, right? So that, forces you to go for vendor lock-in. You go for AWS, you have to use everything in that ecosystem. you go for Google Cloud Functions, you have to use everything in that ecosystem, right? So that's one limitation. Second is the
It's not everything, but your business logic still is controlled, and from your business logic, you can reach out to other services that you may need.
correct.
So that is not limited to their platform.
Correct. So I'll reach to that. Okay. I'll explain how we can overcome that, right?
Okay.
So vendor platform lock-in, there are a few things like abstraction. So for example, instead of writing my core logic into that small piece of function within the AWS user interface or Google interface, what I'll do is I'll write that logic on my server, expose that as an API, and just write a call to that API in AWS or Google. So what I've done essentially is that abstracted out my code here, and as soon as the function is triggered on AWS, it will just take my code from my server and run there instead of me writing my code there. Right. So that's one way to secure yourself from vendor and platform lock-in. You're just keeping your business logic to you. If you want to move clouds, you can do that.
So if you're putting it on your server, now you again have to maintain a server.
Correct. But other parts still you're not doing. What you're doing is just write one. Yeah, and these days exposing API is very simple. Very small piece of code you can write on Python and Java and just expose APIs. Right. Limitation on concurrency by platform. So AWS, Google, they have some limitation that n number of functions you can execute at the same time. After that, it blocks other requests until rest of the functions are traffic apps and services. It could be one of the limitations. Second is they have a time frame. Like within every cloud platform has a different time frame. That 3 minutes, 5 minutes, your workflow, whatever you're using, those functions should not take more than that to get executed. Otherwise, it will just kill it. So that means you can't do machine learning or like transformation using Python or whatever Spark. You can't do that because it's going to take more than 5 minutes. Then they're going to kill your function. Right?
You can't do it if you're using their AWS.
Correct. Yeah. So
if you're using their serverless architecture, but on
if you're building your own and you're tweaking that, then
then you can. You have your own
it needs
PC.
that infrastructure in the back, but you can do that.
Essentially, it makes you write good code.
Yeah, correct.
Right? So
Yes.
you can't write bad code and get away from that.
Correct.
But on the machine learning thing, you can inference doesn't take time, right?
Right.
So,
Inference is training is what
training,
you can't do that. Yeah. And testability, and also what you brought out a point, right? So testability and debugging. I think you brought out that point. This is a bit trickier because they force you to write everything in their function and format. So standard coding guidelines like one class, one responsibility. You should have exception handling, this and that. You don't have to follow any of those. You don't know how well those platforms are handling this kind of situation. So you may have some debugging, maintenance, performance issue from that perspective, not from the execution perspective.
So there is no testing environment. I want to test my written as per all the guidelines, but before exposing it to the actual, I would want to test it, right?
Correct. You can do that. The problem here, testability, is that there are way too many components in picture, right? Everything is a service. So your test cases, test plan has to be so vast, and it has to have inclusion of all of these scenarios. Because so many components, it adds to your permutation combination, right? So that's some sort of leakage in terms of quality. When you're
So where I can put a system.out.println and do some debugging kind of stuff.
He wants an emulator.
No, I mean to just debug.
you don't have to do that, right?
But you trust that the S3.
So like he said, right, forces you to write good code. Instead of writing this much code, just write this, put it in a function, test it out, then again, right? So it's methodology.
I hope Rajesh did it out until this, right? For my poly, we let people write code within the platform, right? External people write code within the platform.
Yeah.
The entire thing was written on AWS Lambda, right? But we limited that to 10 seconds execution per request, right? If it goes more than 10 seconds, we'll kill it, right? We can set that parameter, whatever. So, and for the debugging thing, you can do a console print, but it doesn't come right there. when you can try to execute it and see what is coming out and all those things during testing, unit testing phase, but it will go to a AWS log, right? So that they, I mean, obviously they didn't have access to it, we had access to it to see what was going on. But yeah.
And just to add to that, right, whenever you have scenarios like crowdsourcing and, you want to enforce discipline, this is a great thing, because what you'll do is you'll define 10 functions and force everyone to implement those and write everything within that. If you're doing crowdsourcing and building a product like that, right? Instead of everyone writing whatever they want and then you are having to merge the code base and
So suppose like he said, right, there's a limit 10 seconds, right? When I'm testing it in my environment, there's not much traffic, so I kind of passed it. But in an actual environment, when it failed or it got killed multiple times, so from his perspective, he said that only the people on the server end or where we are hosting, they are able to see the log as to why it got killed and something failed.
So two things, right? One is that that scenario you mentioned is not 100% applicable on cloud platforms because they do have scale. So let's say they're running 2 million functions right now and you introduce 5 more, they'll have additional capacity to execute that. So that scenario will never meet that.
So maybe not traffic. Something got failed, like my code was not correct. And it failed.
So then there's a true microservice architecture comes in place that if it fails, it writes to CloudTrail,
I can go and
CloudWatch, right? And then you write another step that it failed and send me notification with the actual message, right? You can do that.
So that is a way now I think debug what you're doing.
Yeah, it's a different paradigm. Like we having so used to running Eclipse and system.print.lm or Atom, right? Seeing everything there and debugging versus this new microservice, right? This new way of working.
Life sciences domain in the pharma companies, the requirement for validated systems, right? Based on your experience, like conferences or the proposals we have written, do you see them like, what is the penetration of this architecture in the life sciences area, specifically with respect to validated systems?
Correct.
And is there any interest?
Yeah, so this was launched by AWS a couple of years back, and then they are, still promoting and lot of you saw the pricing, right? 20 cents for 1 million requests. Similarly, other platforms are doing. So penetration is not that much, but to answer your question on validation, right? AWS has listed Lambda as one of the GXP HIPAA compliant service, right? So it depends on now on your code, right? Which you will write whether it's validated or not, right?
You have companies in the market that that will actually set up the environment for you based on the HIPAA compliance.
See, GXP,
I understand, but it is like, on safety signal detection, we are probably going to encounter a problem that, the text, the NLP part of it, there is a regular flow of data coming in and getting processed through this engine. But there is also a need that we have to do a periodic training of the model using unsupervised deep learning. Now the question is that, can that part be outsourced as a service, or maybe some components where they may not have the necessary infrastructure, can they reach out to a third party and then bring it in? Right?
So certain aspects of it will fit in a serverless, right? Let's say I want to do a sentiment analysis, right?
Correct.
I mean, simple, it's a microservice. I'm going to call it, I'm going to get positive or negative, what percentage it is. Done,
Absolutely, right?
It's not.
That I'm not going to put it. You know what I'm saying, right? Yeah. It doesn't make sense. It wouldn't work. Five minutes or I think there's a limit of around like 1 minute or 5 minutes for every request.
5 minutes.
It gets killed.
Yeah.
And you don't. It doesn't suit. It is not the way you want to do things. I'm not going to push all those requests in through a REST API. In that case, I will rather put as a file, process a file. It's better, right? So certain aspect would fit in this case, but still looking at the client's maturity curve, where they are and stuff like that, again, this may be a tougher call.
Yeah.
Works well for startups and like high-tech companies, but I don't know how it works.
Yeah, this is not for heavy analytics load, right? I mean, you are doing that, but this is more applicable into a scenario. A lot of our customers in the past, they're like, we are working on Excel and we want to build an app instead of Excel, right? Perfect scenario.
In your case, what it would do is on the cloud spin up a EC2 instance, don't use the Lambda or the the serverless architecture, and execute your stuff. Once it's done, kill the EC2 instance, move the data to S3, right?
Could be more this type.
Yeah, again, there is you're reducing some DevOps, but there is DevOps, right?
But not on your side, right? It's kind of. You can automate. You can automate. You can automate that whole thing.
So the idea is to remove all of that actually. All right, guys, thank you. I think we've reached 1 o'clock.
I think I have one more question.
Yes.
If we run it as a server, it's like, I don't need to worry about initialization part. The service is already running, right? I can make a request, I get a response immediately.
Right.
So I have that time, I know that I'm gonna get a response within, let's say 1 second or 1 microsecond or whatever, right? But with serverless architecture, the first request, it cannot be already loaded. Like the request comes in, the entire process has to get loaded into memory, get initialized and all those things.
Yeah.
And then,
your function is already registered, but it's not initialized. So how long does it take? Plus the actual time of execution is the thing.
So things like
actually, AWS is working on that to remove the startup latency. That's one of the biggest feedback they've got from actual users.
So once it's initialized, do they keep it around, or then they immediately kill it and make it happen again?
They kill it actually right now. So that's why the problem of latency.
So startup latency will be there for every call.
Correct. Yes.
If it is not used often, right? Yeah, then you'll go on with
They have a 30 minutes or 45 minutes, some limitation. After that they remove. So again they have to, but they want to do it like truly available always. They're working on that.
So things like caching would be a problem. If you need something within that function to have caching for repeated requests and stuff, essentially that
why would you want it? Your daily business logic, not on persistence and performance and caching and all that.
So AWS is providing all these services, microservices, and you're not paying for any of that. You're only paying when you use it.
Yes.
And every time you use it per call, a million calls you
depending on service, there is a per call, per hour, per GB, depending on what service you're using.
So this is their revenue model. They just keep making money every time you call.
Yes. And that's how they
Isn't
recover
that like a
losses from
disadvantage though, that instead of us taking a one-time hit but then owning it every time you want to run it?
No, it depends on the load that you have, right? It's capital investment versus operational.
So nowadays, actually, all startup companies go, this.
Right, guys.
Then they are
On phone, any question?
Whatever you're going to be paying anyway.
Right, thank you.
Thank you.